You're listening to DTFHN for June 2nd, 2026. I'm your warranty-voiding host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who mass delete their browser tabs call it spring cleaning. Today's stories are a masterclass in finding unlocked doors and walking right through them. Buckle up, nerds. 784 kilobytes. That's a tire compiled binary for a JET program, not the source code. The finished executable with a full runtime garbage collector and bytecode compiler baked in. You could fit it on a floppy disk and still have room for another one. Janet is a Lisp. I know, parentheses. In the year of our Lord 2026. But before you close this tab, metaphorically, since you're listening to a podcast, consider that someone loved this language so much, they wrote an entire free book about it. Not a blog post, not a tweet thread, a book, and then gave it away. That's the kind of energy we're dealing with. The devil's advocate move here is obvious. Why do we need another programming language? We have Python for scripting, Rust for binaries, Bash for shell stuff. The world is drowning in languages. Every new one is a mass extinction event for someone's weekend. But here's where that argument collapses. Janet isn't trying to replace any of those. It's occupying a space that barely exists. The language has 8 core instructions. 8. The entire standard library fits on a single page. You can learn it in an afternoon, and by the end of that afternoon, you can compile a native binary that you hand to someone who has never heard of Janet. And it just runs. No runtime installation, no dependency hell, no Docker container cosplaying as a solution. The parsing story is genuinely wild. Instead of regular expressions, those eldritch incantations we all pretend to understand, Janet uses parsing expression grammars, which means it can parse HTML. It can parse JSON. It can handle binary formats with no bytes. These are real parsers, composable and first class, not regex duct-taped to a prayer. And there's a shell scripting DSL that lets you write Unix pipes directly in Janet. Find, pipe, redirect. All in a Lisp. Someone looked at Bash and thought, you know what this needs? Parentheses. And somehow they were right. The compilation trick is beautiful in its simplicity. Janet compiles to bytecode, writes that bytecode into a C file alongside its own runtime, then compiles the C. It's embedding itself into itself. The snake eating its own tail, except the tail is a perfectly functional command line tool under a megabyte. This is builder culture at its finest. Ian Henry didn't just adopt Janet. He wrote the documentation the ecosystem needed, then published it for free. That's bootstrapism. You find the ladder. You extend it. You leave it where others can reach it. The tools exist. The book is available. The binaries are tiny. Sometimes the most radical thing a language can do is just get out of your way. Moving on. I've spent enough years building hardware projects to know that when someone finds your server misconfiguration, the correct response is to fix the server, not to call a former FBI chief of staff. Let me lay out what we know. Adafruit, one of the most respected names in open hardware, discovered something about Flux.ai, a PCB design tool. Through publicly accessible data that Flux's own systems exposed, Adafruit prepared to publish findings related to Flux's intellectual property claims, their commercial traction, their user base. Standard reporting, the kind of accountability journalism that keeps an industry honest. Flux's response was not to address the substance. It was to send a legal threat at 10:38 at night. invoking the Computer Fraud and Abuse Act. A law so notoriously broad it was used to prosecute Aaron Swartz for downloading academic papers. And the result? Adafruit, a company that has published freely and openly for years, has gone silent. The blog is dark. The community is left guessing. The question nobody wants to ask directly is this: what exactly is Flux hiding? Because companies with nothing to hide don't retain partners at Fenwick and West to fire off demand letters before an article even publishes. Companies with legitimate products and real traction welcome scrutiny. They open their metrics. They let the work speak. That is what confidence looks like. What we're seeing here looks like the opposite. The CFAA claim deserves particular attention. Adafruit accessed information that was publicly available due to Flux's own misconfiguration. This is not hacking. This is reading what someone left on the front porch, weaponizing computer fraud statutes against security researchers and journalists who find what you accidentally expose. That is a pattern we've seen before, and it always serves the same purpose. It chills disclosure. It punishes the people who find the problems instead of the people who created them. Adafruit signed their post with two names, Ladiata and PT, Lemmer-Fried and Philip Tyrone. These are people who have spent decades putting tools, tutorials, and open hardware into the hands of anyone willing to learn. They represent exactly the kind of builder culture that makes this industry worth caring about. The community reader comments tell you everything. Someone pointed out the irony perfectly. If Flux wanted nobody to know about this, congratulations to their lawyers for making sure everyone does. Adafruit will respond. The facts will come out. They always do when one side is willing to publish and the other side is sending cease and desist letters at 11 o'clock at night. Moving on. 14 lines of CSS. That's the entire Parallax implementation. Not a library. Not a framework dependency. Not a scroll event listener firing 60 times a second on the main thread. 14 lines of declarative styles that you can drop onto any element with a single utility class. Let's break down what's actually happening here, because the engineering is genuinely elegant. The key insight is a property called ViewTimelineName. What it does is create a progress timeline tied, not to clock time, but to how far an element has traveled through the viewport. 0% when it enters, 100% when it leaves. That's your animation clock. No JavaScript, no request animation frame, no debouncing scroll handlers. The browser's compositor handles the entire thing off the main thread, which means your parallax effect runs at the same priority as native scrolling. The child element gets animation timeline pointed at that same named timeline, and from there, the keyframes do exactly what you'd expect. Translate from -20% to +20% as the parent scrolls through. Different rate than the container. You get depth. That's parallax reduced to first principles. But here's the detail worth pausing on. The scale calculation. When you shift a child element up or down inside its container, you expose empty space at the edges. The obvious fix is to make the child bigger. The less obvious fix is to make it exactly the right amount bigger. Automatically. The formula reads the same CSS custom property that controls the parallax offset, doubles it, and adds it to the base scale, one variable. Tune the strength of the effect, and the overflow compensation adjusts itself. The gaps never come back. That's the kind of engineering where someone thought 3 steps ahead so you don't have to think at all. One of the reader comments asked why the article itself wasn't a live demo of the effect. Fair point. Another link to CodePen, but the real demo is the code block itself. You can read the entire implementation in less time than it takes to npm install a Parallax library. This is what the web platform looks like when it matures properly. Scroll-driven animations landed in browsers as a native capability, and immediately the ecosystem of JavaScript workarounds starts becoming unnecessary weight. The platform absorbs the pattern. The abstractions get thinner. The performance gets better because the browser knows what you want and can optimize for it. 14 lines. Runs on the compositor, one custom property to tune. This is how standards are supposed to work. Now, story 4. The newest Instagram exploit just dropped, and honestly, it's the funniest one yet. Someone in the comments thread put it perfectly. Quote, "Who looked at password resets and went, yeah, let the chatbot handle that one," end quote. And that single sentence contains the entire post-mortem. Here's what actually happened. Meta rolled out an AI support agent to a subset of Instagram accounts through A/B testing. This agent had one job: help users recover locked accounts, and someone discovered that if you spoofed your location with a VPN to match the target city, you could tell this AI agent that you'd been hacked. Give it any email address you wanted, and the agent would dutifully send a verification code to that arbitrary address. The attacker catches the code, feeds it back, and the system hands over a full password reset link. Account transferred. Done. The engineering craft angle here is fascinating in the worst possible way. This is a textbook example of tool permission architecture gone wrong. Another commenter nailed the deeper principle. When thinking about the security of AI agents, ignore the agent entirely. Consider only the tools it has access to. Assume the attacker can interact with it. That's the threat model. And Meta gave this agent the ability to send authentication codes to addresses with zero verification that those addresses belonged to the account holder. The AI didn't get tricked into doing something clever. It did exactly what it was designed to do. The design was just broken. Two-factor authentication. Bypassed completely because the system treated this as a total account reset by the rightful owner. Existing sessions revoked. Password changed. No notification sent to the actual owner. The real account holder couldn't even initiate recovery because all their contact information had already been remapped. And if you were in the A/B test group, you couldn't opt out. Pull this thread toward the bootstrapism question, and something uncomfortable emerges. This is a closed system failing in exactly the way closed systems fail. No external audit. No open protocol for account recovery that the community could inspect. No way for security researchers to examine the tool permissions before black market Telegram groups figured them out. $1.5 trillion company shipped an agent with root-level account mutation capabilities, and the only verification was vibes. The Telegram markets were charging steep rates for account takeovers. Short Instagram handles worth hundreds of thousands of dollars were getting flipped. The Obama White House account got hit. The Chief Master Sergeant of the Space Force. Meta says it's patched now, but reports suggest variants are still circulating. Open security review isn't a nice-to-have. When the tools are this powerful and the architecture is this opaque, the question isn't whether it breaks. It's how long it stays broken before anyone outside the company even knows. We talked about putting AI in your pocket earlier. Well? Someone went ahead and put an entire computer in your wallet. What does it actually mean for a computer to be credit card sized? Not credit cardish, not approximately, the dimensions of a card, if you squint. Actually, physically, indistinguishably the same size as the Visa in your wallet. 0.76 millimeters thick. ISO 7816 spec. The standard that every payment terminal, every card slot, every wallet pocket on Earth is built around. A maker named Counsel just published the Muxcard, an ESP SUM with an e-paper display and NFC, built onto a flex PCB thin enough to fit inside the housing of an actual NFC smart card. The frame is literally a carved-out contactless card with the electronics seated inside it. Total thickness target, around 1 millimeter. Pull this thread for a second. The ESP32C3 is a RISC-B core, Wi-Fi Bluetooth Low Energy, runs at 160 megahertz, and it fits with a display and an antenna in something you could accidentally leave in your back pocket and never notice. The build process is worth your time. Chrysler got impatient waiting for a flex PCB fab. Weeks of shipping, customs delays, the risk of a single footprint mistake turning the whole batch into expensive confetti. The solution? Use a 3D printer as a UV lithography machine. Kapton tape with laminated copper foil, photoresist layer, chemical etching. Software called UV Tools to export copper layers in a format the printer accepts. After dialing in the chemistry, developing times, concentrations, curing parameters, the resolution matched what most commercial fabs deliver for standard orders. This is a fully open project. GitHub repo, schematics visible, process documented. Someone with a resin printer, some Kapton, and enough stubbornness can reproduce this. The architecture question answers itself. Anyone can fork it, improve it, adapt it. Offline password manager, two-factor authentication token, NFC access key, QR code wallet. The use cases multiply precisely because no one controls the platform. One comment asks if it can run Doom. Probably not yet, but the fact that the question is even plausible for something a millimeter thick tells you where the floor is for computing in physical spaces most people assume are too small to matter. The whole repo is right there. The tools exist. The process is documented. Go build one. We talked earlier about who controls the future. Well, Wall Street's about to find out if it can even afford a seat at the table. $4 trillion. That's the combined market cap these three companies expect public investors to absorb in a matter of months. SpaceX, Anthropic, OpenAI. Each one individually would be the largest IPO in history. Together they're asking the American stock market to conjure the GDP of Germany and hand it over. One of the reader comments cuts right to it. They changed the rules so that over $30 trillion in passive retirement money has to buy in at IPO valuations. Index funds don't get to say no. The moment SpaceX hits the NASDAQ, every 401k tracking the index becomes a forced buyer. That's not price discovery. That's a funnel. Let's pull this thread. Anthropic at $1 trillion valuation against Google's $23 billion IPO in 2004. Sounds absurd until you compare revenue. Google was doing $2.7 billion, Anthropic's already at 47. The multiple is actually more reasonable than Google's was. The question isn't whether the math works on a spreadsheet. The question is what you're buying. With Google in 2004, you are buying a search monopoly with a moat made of data and distribution. With these three, you are buying a bet that closed AI labs will maintain pricing power in a world where open weight models keep closing the capability gap every few months. Llama, Mistral, DeepSeek, Quinn. The open ecosystem isn't standing still. Every quarter, the frontier gets cheaper to reproduce. Another commenter nailed the timing angle. They're racing to IPO before the music stops. Getting public and raising cash is a one-way door. Even if the stock craters afterward, the company has the money. That's not confidence in long-term value. That's a liquidity event dressed up as a coming-out party. Run this forward. If open models continue compressing the gap between frontier and commodity, the moat for these companies isn't the model. It's the brand, the enterprise contracts, the regulatory capture. And regulatory capture is just another way of saying the ladder got pulled up. The fascinating part is that Anthropic, the company whose whole pitch is safety and responsibility, is seeking the same valuation as OpenAI, the company whose whole pitch is move fast and ship. The market doesn't care about your mission statement. It cares about your revenue line. Both companies know this, which is why they're both sprinting for the same exit. The tools to build competitive AI are increasingly available to everyone. The question these IPOs really answer isn't whether the stock market can absorb $4 trillion. It's whether $4 trillion of public money should be betting that openness loses. Moving on. In 1995, Microsoft shipped Windows 95 with a taskbar and a start menu. And for the next decade, every operating system converged on roughly the same idea. Spatial organization. You put things in places. You remembered where they were. Your brain did the rest. This was not a design philosophy. It was a concession to how human cognition actually works. We are, at our core, wayfinding animals. We remember locations better than labels. Apple understood this. In 2006, macOS Leopard shipped Spaces, and it gave you a grid of virtual desktops, 3 by 3. 9 screens you could navigate with muscle memory. The same way you'd glance left to check a second monitor. Your browser lived in the center. Your editor lived above it. Xcode top left. Simulator below. You didn't think about switching. You just moved. Then in 2011, Lion flattened the grid into a single horizontal line, and 15 years of spatial memory became worthless overnight. Run this forward. Imagine you've spent 5 years training your hands to reach for 9 distinct locations, and someone replaces your desk with a conveyor belt. Everything's still there. You just have to scroll sideways to find it. The efficiency loss isn't dramatic enough to revolt over. It's just enough to make you slightly worse at your job forever. Death by 1,000 horizontal swipes. The author of this piece did what builders do. They built an app to get the grid back. No framework dependency, no system integrity bypass, just a tool that restores what Apple took away for reasons no one at Apple has ever coherently explained. The comments are full of people describing elaborate Rube Goldberg stacks of window managers, terminal multiplexers, and tiling tools, each one compensating for the same missing primitive. One person's workflow nests 4 deep: NeoVim, Tomox, Ghosty, Rectangle, then the OS. 4 layers of software to approximate what the operating system used to do natively. This is the comedy. Apple removed a feature that worked, and an entire ecosystem of third-party tools sprouted to replace it, each one more complex than the original. The grid was 14 years ago, and people are still rebuilding it from spare parts. The tools exist. The spatial model is proven. One developer just shipped it. That's how open source wins. Not by arguing about philosophy, but by building the thing the vendor won't. Now for something completely different. Story 8, CQL, Categorical Databases. This one gets mathematical, and I am here for it. Let me make the strongest case against CQL first. SQL won completely. Edgar Cod published a relational model of data for large shared data banks in 1970, and within 2 decades, relational databases consumed the entire industry. Every challenger since. Object databases in the 90s, XML databases in the early 2000s, even the NoSQL movement of the 2010s. Eventually bent the knee or found a niche so small it barely registers. The relational model is arguably the most successful abstraction in the history of software. Why would anyone bet against it with, of all things, category theory? That's the honest objection. And one of the Hacker News commenters raises exactly this point. Show me the paper that demonstrates categorical databases escape COD's dominance proof. It's a fair demand. But here's where the objection breaks down on its own terms. COD's model solved storage and retrieval. It did not solve transformation. Anyone who has spent a week migrating data between two schemas, or tried to merge databases from an acquisition, or watched a data engineering team burn months building ETL pipelines that are essentially hand-coded morphisms between incompatible structures. Those people know. The relational model tells you how to store data. It says almost nothing about how to move data between representations while preserving meaning. This is precisely what category theory was built to describe. Functored. Structure-preserving maps between categories are not an abstract curiosity here. They are the formal machinery for saying, this transformation guarantees your constraints survive the journey. CQL does not replace your database. It sits above it, providing a mathematically grounded language for the part SQL was never designed to handle. The project is open source. The IDE is available. Ryan Wisniewski and the team have been publishing the underlying theory for over a decade, building on David Spivak's work at MIT connecting category theory to database schema design. This is not a weekend project repackaging familiar ideas. It is a serious, long-running research effort that has reached the point of production readiness for in-memory workloads. The historical parallel that matters is not SQL versus its challengers. It is the relationship between assembly language and compilers. Nobody argued that compilers replaced machine instructions. They argued correctly that humans needed a higher-level language to reason about the transformations they were already performing by hand. CQL is making the same bet. That the ad hoc data wrangling every organization does today deserves a formal language, and that category theory is that language. The tools exist. The math is proven. The code is open. Now for something completely different. OpenAI's frontier models and Codex just landed on AWS. And yes, that sentence is real. Amazon Web Services just became an OpenAI reseller. And the enterprise comments are telling you exactly why this matters more than any benchmark ever could. Think of it like plumbing. Every large enterprise has spent years, sometimes decades, building out their AWS infrastructure, the pipes, the valves, the pressure regulators, security reviews, compliance frameworks, billing systems, vendor approvals, all of it threaded through AWS. Now imagine you're a pharmaceutical company, like Amgen, and you want to use a frontier AI model. You don't just call OpenAI and swipe a credit card. You go through procurement, you go through security review, you go through legal. One commenter nailed it. In some companies, getting a new vendor approved is nearly impossible. But if the model shows up inside the plumbing you already have, that's a Tuesday afternoon deployment instead of a 6-month procurement odyssey. This is the move that should genuinely concern Anthropic. Claude's early enterprise traction came substantially from being available on Bedrock when OpenAI wasn't. That moat just evaporated. The comments are remarkably honest about this. Multiple enterprise engineers saying they picked Claude specifically because it was the frontier model available through their existing AWS contracts. Now they have options. Here's what's worth noting from the open systems perspective. This is two closed ecosystems merging their distribution channels. OpenAI's proprietary models, delivered through Amazon's proprietary cloud, with governance frameworks that lock you deeper into both. The engineering is impressive. The convenience is real. But every layer of integration is another layer of dependency. When your AI capabilities are mediated through a platform you don't control, running on models you can't inspect, the question isn't whether it works today. It's what happens when the pricing changes, when the terms shift, when the objective function updates. The plumbing metaphor cuts both ways. Convenient pipes are still pipes, and pipes determine where the water flows. And sometimes the pipes lead somewhere genuinely delicious. Chipotlai Max is serving up something worth tasting. I've spent enough time building proxy layers and API shims to know that the hardest part is never the engineering. It's keeping a straight face when you realize the production system you're reverse engineering has zero authentication on its inference endpoint. Chipotlai Max is exactly what it sounds like. Someone discovered that Chipotle's customer support chatbot, Pepper, powered by IPsoft's Amelia platform, could solve LeetCode problems and write Python. Then a developer named Gunsai reverse-engineered the WebSocket backend, built an OpenAI-compatible proxy, and the team forked OpenCode. 120,000-star MIT licensed coding agent. To ship a fully functional AI development environment powered entirely by Chipotle's cloud budget. A PI key, set it to Burrito 2026. Literally anything works. Now let me play devil's advocate. You could argue this is just theft, unauthorized access to corporate compute. The CFAA concerns in the comments are real. That law has teeth, and courts have applied it broadly. A reasonable person might say this crosses a line. But examine what actually happened here. A corporation deployed an AI system on the public internet with no authentication, no rate limiting worth mentioning, and enough capability to function as a general-purpose coding assistant. The engineering craft in the exploit is genuinely beautiful. SockJS plus Stomp protocol, reverse engineering, session pooling, a clean OpenAI-compatible completions endpoint. This is the kind of work that security teams should be thanking people for, not suing Open. What I love most is the contributing section. Pepper got patched, so now they're crowdsourcing reverse engineering of every major retailer's chatbot. Home Depot, Starbucks, McDonald's, all listed as needs research. It's a distributed security audit disguised as a meme project. The real lesson isn't about free inference. It's that every company rushing to deploy AI chatbots is simultaneously deploying unsecured compute endpoints. The builders found them first. Next time, it might not be someone making jokes about extra guac. This has been your daily tech feed for Hacker News for June 2nd, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go find something that needs building and make it yours. We'll see you back here tomorrow.